the mics around me, right?
I'm just pointing about every phase.
Good Lord, you guys are killing me. I've never had a class like this. Can you speak in personal space? Personal space. Oh, you got to do his bubble.
Everybody's bubble.
All right. So if everybody's ready?
Yeah.
All right, starting at the top, 3, 2. All right, starting at the top here with the ADIRS panel. With the ADIRS panel, we've got an on-bat light, and the on-bat light, it will come on as a test. If I were to look up on the overhead and notice that the on-bat light is on steady, it means that one or more of the IRs are being powered by the batteries. Now, if they're being powered by the batteries, I've got 5 minutes to recover the electrical system. All 3 will be powered. After that 5 minutes, I'm going to drop a couple. And it's the ones that the captain isn't using. Typically, that's going to be IR number 2 and number 3. Unless previously selected on the attitude and heading panel, captain has been selected on 3, then the 2 that will get dropped are IR number 1 and IR number 2, keeping the captain's power. Next thing I have is the fault light. If I look on the IR and notice that I have a solid fault light, it means that that gyro has tumbled. It is no longer a good gyro for anything, attitude, heading, or navigation. If I were to look up and notice that an IR is flashing fault at me, it means that it may be recoverable in attitude and heading, all right? So I would have to select out of nav, put it in attitude, and then give it a position so it has an idea of where it's at. I would type in a magnetic heading. If I look at the align lights, if they're all 3 solid align, it means that I'm in the alignment process, which takes 10 minutes total time on a full alignment. If I look on the overhead panel and I see that the align lights are flashing, it's one of 3 things. I haven't given it a present position within that 10 minutes. I've given it a position that disagrees from its last shutdown by more than 1 degree or 60 miles, or there was an alignment fault, such as aircraft was sufficiently moved during the alignment process. ADRs, very simple with that. If I have a fault light on an ADR, it means that the pedostatic system on that side has been lost, and I would deal with the switching panel, air data, putting captain or the first officer on the number 3, the backup if necessary. With the flight controls, I have ELACs, which stand for Elevator Aileron Computer, and the primary computer for the ailerons is ELAC 1. The primary computer for the elevators is ELAC 2. Spoiler Elevator Computer, SEC, its primary computer job is for the spoilers, but it can, in a backup mode, control the elevators. Flight augmentation computers. The flight augmentation computers, they give us the speed tape symbology, F, S, green dot. They are dealing with the flight envelope. They give us the indication of low energy warning, wind shear protection, and flying the tail, as in turn coordination, yaw damping, rudder trim, and rudder travel limits. The evac, simple on that one. If I lift the guard and push evac, it sends the tone to the back, allowing the flight attendants and the people in the back to know that there's an evacuation situation going on. We will hear a high frequency tone, a beeping, and I will hit evac horn shut off. It is a very loud system. We lock it into the captain, so the captain is the one that will initiate the evacuation command only from the front. Flight attendants have their own system in the back. On the emergency electrical power panel, Gen 1 line, if I were to see smoke, it means that there is smoke in the avionics compartment. I will have some confirmation lights over on the ventilation panel. On the blower and the extract, they would both show fault. That is the confirmation that there is smoke in the avionics. When I push the Gen 1 line to off, what I am doing is I'm taking generator number 1 off the electrical system, and I'm going to dedicate it to the number 1 fuel pumps in the left and right wings. RAT and emergency generator. If I see the red fault light, it means that the emergency generator should be powering, and it's not. If I see that fault light, I will lift the guard and push the button. GPWS. If I have a fault on terrain, it means that the terrain system has been lost, the database. I will turn that off. I will still get my basic modes of GPWS for too low flaps, too low gear, and recognizing terrain. If I have a fault with the system, that means that I have lost all of those modes, including the enhanced GPWS. Glide slope mode and flap modes, these are for abnormal conditions to where I will turn that mode off. Landing flaps 3, that is a selector that I can turn on. I would do this in the event that I am planning on doing a flaps 3 landing. If I do that, I need to come into the MCDU on the performance page and also select config 3. Cockpit voice recorder. When I walk out to the aircraft and I turn on external power, the CVR is powered for 5 minutes, and then it turns off. In order for the captain to get the briefings and the checklist, they are to turn the cockpit voice recorder on, and they do a CVR test. They should hear a tone. If the CVR does not test, the most likely scenario is that the parking brake is off. The cockpit voice recorder comes on automatically after engine start. Oxygen. System on means that the signal has been sent to the doors in the back to drop the masks. It happens automatically at 14,000 feet cabin altitude. Or if I lift the guard and push it, I can deploy the masks manually. Crew supply, that is to allow the oxygen bottle to connect up to the manifold for the cockpit masks. If it is off, I will have no pressure going to the manifold. Calls, we can contact the forward and aft cabin and also the mechanics by pushing that button. It will be a single chime for each, the forward and the aft. If I lift the guard and push it for emergency, it is a triple high-low chime. Wipers, speeds, slow and fast. Wiper limit speed is 230 knots. APU, when I turn the master switch on, I am powering the electronic control box. I am pressurizing the fuel pump if it is necessary. I will be opening the APU flap, the inlet, and bringing up the ECAM page for the APU. Starting it will start the process to where it will crank the motor and start the APU. Once I see the green avail, it means that the APU is on speed. If I see a fault light on the APU master switch, it means that the last shutdown was abnormal. If it was due to a fire, I could look up on the APU fire panel and notice that there is a discharge. The APU can auto shut down for a multitude of reasons on the ground, including a fire with an auto extinguish. In flight, the APU can auto shut down for multiple reasons. However, it will not auto shut down and not auto extinguish for a fire. Anti-ice. On the wing, the outboard 3 slats are anti-iced. The default position of the anti-ice valve for the wing is closed if it were to lose its electrical signal. A fault light on the wing anti-ice means the air pressure is low or there is a valve switch disagreement. On the engine, I am heating just the nacelle lip. The default position of that valve is open if it were to lose electrical signal. The reason for a fault light on the engine anti-ice is in the event that there is a valve switch disagreement. probe window heat. As long as there is external power or another power source on the aircraft, the drain masts are powered. If I were to push the probe window heat switch on manually, I would be heating all of the probes and all of the windows except the total air temperature. If the probe window heat switch is in auto, the probes and windows will become heated at engine start. That would include all of the probes, all of the windows, except the total air temperature. The total air temperature probe is only powered, that heat is powered when I am airborne. Cabin pressurization. I have two automatic controllers, System 1 and System 2. They change over after each landing or in the event of a system failure. Landing elevation, rotary selector. In auto, it gets its landing elevation from the FMGC. The events where I would have to take the landing elevation out of auto would be if the airport that I'm going to is not in the database is incorrect, or ECAM or an abnormal procedure would give me guidance to do that. If I take that rotary selector out of the auto position, I still get automatic pressurization. I've only changed the schedule to when the outflow valve will open. When I push the ditching switch, the aircraft in automatic will close all the holes below the waterline. Those valves are both pack valves, avionics inlet, avionics outlet, the ram air valve, and the outflow valve. Again, provided that I am in automatic. If the mode selector has a fault light on it, it means that both automatic system controllers have failed and I must go to a manual condition. And the outflow valve will now be controlled by the manual vertical speed control. Up opens the outflow valve, down closes the outflow valve. The ditching switch, if I were to push at that point, all valves would close except the outflow valve. On the pneumatics page, the engine bleed. If I were to get a fault light on the engine bleed, it means that there is a leak, overpressure, over temperature situation, or the engine bleed is open during an engine start, or the engine bleed is open with the APU bleed being open. Fault light on the APU bleed represents a bleed leak. The ram air push button, if I were to push that on, the valve will not open until there is less than 1 psi differential. The scoop will open, but the valve will not. The air conditioning packs, if I have a fault on the air conditioning packs, it means that there is a overheat or a valve switch disagreement with the air conditioning pack. The pack flow selector is a demand switch. If I select low, I can get low flow if I am operating with 2 packs and engine bleed air. The 2 times where I will get high flow regardless of that switch position is if I have APU bleed supplying the bleed air or single pack operation. I will get high flow regardless of that position. The hot air valve, if I have a fault light, it means that there is an overheat. The electrical panel, minimum battery voltage that I need to have when I initially show up to the aircraft is 25.5 volts. That check is only valid when the battery switches are off. If the battery switches are in auto, the batteries will connect up automatically under these 3 circumstances. They are the sole source of electrics, they need to charge, or when I start the APU. A fault light on the battery means that the battery charger is out of limits. A fault light on a generator means that the line contactor is open or there was a GCU trip. Fault light on the IDG means that the IDG has high oil temperature or low oil pressure. Important point is that when I lift the guard, it is a momentary push, less than 3 seconds, and the engine has to be rotating in some way, shape, or form. Priority of powering the electrical system, powering a particular AC bus, number 1 priority is on-site generator. Number 2, external power. Number 3, APU generator. And finally, opposite side generator. If I get a fault light on the AC essential feed, it means that the AC essential bus is not being powered. When I push it to alternate, it will now get its power from AC bus 2 to power the AC essential bus. In the event that I am operating with a single generator, I will get an automatic galley shed, which is the high demand devices, the ovens. I must have 2 generators in order to get the entire galley system. If I have 2 generators, but one of them has become overloaded, I will get a fault light on the galley and cabin switch. That means that I have one of my generators is at 100% load. At that point, I push that switch to off, and that will shed the entire galley system. If I lose both AC bus 1 and AC bus 2 in flight above 100 knots, even on the ground above 100 knots, I will get an automatic ram air turbine deployment. During that time, the aircraft will be powered by batteries only. My indication would be the primary flight display and the engine warning display would be visible. All other displays would be blank. After approximately 8 seconds, the emergency generator would couple and I would gain 2 buses. I would be powering the captain's primary flight display, captain's nav display, engine warning display, and the number 1 MCDU. Coming in on my approach, eventually when I get to a low enough speed, between 125 to 140 knots, the emergency generator would drop offline and I would again be powered by the batteries. That would be noticed by the loss of the captain's nav display and the number 1 MCDU. So I would have only the captain's PFD and engine warning display being powered. After touchdown less than 100 knots, I would gain the DC battery bus. I would not notice any change in the cockpit. When I drop below 50 knots after landing, I would lose the AC essential bus and all of my screens would go blank. The only buses that would be powered would be the DC essential bus and the DC battery bus. The DC essential bus allows me to have number 1 communication on VHF number 1. The fuel is filled from the outer tanks and it spills into the inner tanks. If the fuel is required to have center tank fuel, it will also fill that simultaneously. Fault lights on the fuel pumps mean that the pump pressure is low. When I have center tank fuel, when I start an engine, the center tank pump will run for a minimum of 2 minutes. In order for that center tank pump to stop running, I must have a minimum of 2 minutes and the slats extended. At that point, the center tank pump will stop. When I start the second engine, the center tank pumps will again start running for that minimum of 2 minutes. So that way I will be tank to engine for takeoff once it shuts off. Once I am airborne and I retract the slats, the center tank pumps will start operating again. Fuel that is going to the engines, there will be an IDG return line that is going to the outer tanks. This is filling the inner tanks at that time. Eventually the inner tanks will become full. They will send a signal to the center tank pump to shut off for approximately 1,100 pounds of fuel flow. After 1,100 pounds of fuel has been burned, the center tank pump will get the signal to start running again. If this does not work and the inner wing tanks continue to burn, once they are less than 11,000 pounds in the wings and more than 550 pounds in the center, I would get a fault light on my mode select switch which would force me to turn it to manual. If the system is working normally, when the center tanks eventually reach 550 pounds, they will continue to run for an additional 5 minutes, and then they will shut off for the remainder of the flight. I will now be burning out of the inner wing tanks at approximately 1,650 pounds in those wing tanks. It will send a signal to open the transfer valves, allowing the outer tanks to drain into the inner wing tanks. Those transfer valves will close at the next refueling. Hydraulics. Things that are unique on the green hydraulic system are the #1 reverser, normal brakes, nose wheel steering on some aircraft, normal and auto brakes. Things that are unique on the yellow hydraulic system: the #2 reverser, nose wheel steering on some aircraft, alternate/parking brake, and the cargo doors. Things that are unique on the blue hydraulic is the ram air turbine. If I lose blue hydraulic fluid, the ram air turbine would not be available for emergency electrical backup. The reasons for fault lights on the engine-driven pumps are pump low pressure, reservoir low level, reservoir low air pressure, and reservoir overheat. The reasons for fault lights on the electric pumps are pump low pressure, reservoir low level, reservoir low air pressure, and reservoir overheat, and pump overheat. All of the pumps will pressurize the hydraulic system to 3,000 psi. The ram air turbine can pressurize the blue hydraulic to 2,500 psi. The PTU will connect up the green and yellow system when the differential pressure is greater than 500 psi between the two systems, unless it is inhibited. The inhibits for the PTU are when the engine master switches are mismatched, one on, one off, with the parking brake set, or one on and one off, and the toe pin is installed. The third inhibit is during cargo door operation. If I have just a fault light on the green engine pump, it means that there is pump low pressure, because the PTU would pick up the slack. If I have a fault light on the green engine pump and the PTU, it means that there is a reservoir problem. Reservoir low level, reservoir low air pressure, reservoir overheat, and I need to turn off both pumps to keep from cycling that bad fluid. So in that case, green engine pump and the PTU. Fire system on the engines, 2 loops. Both loops must detect a fire to get a fire indication, or one loop was already detected as being faulty and then the other loop detects a fire, or both loops physically break within 5 seconds of each other. There are fire detection sensors that are placed in 3 points on the engine. They are in the fan section, the core, and also in the pylon nacelle. If I get a fire indication, I lift the guard and push it. I will arm the squibs, silence the continuous repetitive chime, and isolate hydraulic, fuel, electrics, and pneumatics. To be specific, if I were to lift the guard and push it, it's going to arm the squibs, silence the CRC, close the hydraulic fire shutoff valve, the fuel low pressure valve, and the IDG return. It would deactivate the generator. It would close the engine bleed and the pack valve. For the APU, if the fire indication comes about, I lift the guard and I push the fire push button. It would arm the squib, silences the CRC, and isolate fuel, electrics, and pneumatics. To be specific, if I open the guard and push the button, it's going to arm the squib, silence the CRC. It would close the APU low pressure fuel valve and de-energize the APU fuel pump. It would deactivate the APU generator, and it would close the APU bleed and the cross bleed valve. For the cargo heat system, a fault light on the hot air means that there is an overheat. For the aft isolation valve, it means that there is a valve switch disagreement. On the ventilation, I have 3 normal modes of operation: open, closed, and intermediate. It depends on whether or not I'm on the ground or in flight and the skin temperature. On the ground, I can get open and closed only, depending on the skin temperature. In flight, I can get closed and intermediate, again, depending on the skin temperature. Reasons for fault lights on the blower are computer fault, low pressure, and duct overheat. Reasons for fault light on the extract: computer fault and low pressure. Fault light on both the blower and the extract is for smoke in the avionics. If I push either the blower or the extract to override, I get a closed circuit configuration and I add air-conditioned air. If I push them both for smoke, I get a smoke configuration. I will add air-conditioned air, I will open the small outflow flap, and the blower fan will stop. Flight controls. If I am fully electrically and hydraulically powered, I will be in normal law. When I'm on the ground and I do a flight control check, pulling full back for full up, full down, full left, full right, I am getting a direct relationship between the side stick and the control surface deflection. I am in normal law, but I'm in a ground mode. When I become airborne, it will blend into the flight mode. Upon arrival, at 50 feet, the aircraft will take a picture of the deck angle. It will, at 30 feet, start to introduce a slow pitch down input, causing me to pull against the springs in the side stick, giving me an artificial feel for landing. This is the flare mode. After touchdown, it will again revert to the ground mode. In the flight mode, the maximum bank angle that I can impose upon the airplane with the side stick is 67 degrees. That can be indicated by green equal signs on the primary flight display. Once I go beyond 33 degrees, the aircraft will stop auto trimming. If I release a side stick, it will go to an angle that is 33 degrees. The maximum pitch that I can impose upon the airplane with the side stick is 20 to 30 degrees nose up, depending on the configuration and speed. It will be indicated by green equal signs on the 30-degree pitch mark. For pitch down, the maximum pitch I can impose is 15 degrees nose down, all cases, all configurations. That is also indicated by green equal signs at the 15 degrees nose down mark. For angle of attack, the symbology, the amber hook represents VLS. VLS stands for lowest selectable speed. I can select lower, but the auto flight system will try to prevent me from going slower than VLS. The yellow and black tiger tail is the beginning of the angle of attack protection range. Once I get into the angle of attack protection range, the aircraft bank would be limited to 45 degrees. If the autopilot were on, it would kick it off. If the speed brakes were extended, it would automatically retract them. The side stick is no longer load demand in pitch, it would become angle of attack demand in pitch. And the pitch up trim would be inhibited starting at the top of angle of attack protection. If I were to let go of the side stick, that is the speed it would go for. Somewhere before angle of attack max, I may have alpha floor. Alpha floor is an auto thrust function. Auto thrust does not need to be armed or engaged to get it. It just has to be a serviceable system. When alpha floor is engaged, an FMA in column 1 for the auto thrust would come in green, and alpha floor means that I am getting toga power and I have a bad AOA. When I resolve the AOA, it becomes toga lock. It is one and then the other. The red bar in normal law represents alpha max, the maximum angle of attack that I can impose upon the airplane with the side stick. I cannot stall the airplane in normal law. High speed. VMO is 350, MMO is 0.82. There will be a green equal sign that is 6 knots above VMO. That is where the high speed protection begins. If I invoke the high speed protection, the aircraft would automatically, with no stick input, would roll wings level and would pitch up. This pitch up command is non-overridable. Once I am outside of that green equal sign, I can reintroduce a pitch down and reaccelerate the aircraft. 2 ways of getting out of normal law. Number 1, multiple failures of redundant systems. Number 2, an abnormal upset. If I have multiple failures of redundant systems, I will no longer be in normal law. Protections that I will lose. In alternate law, I will lose my bank protections. I will lose my pitch protections. I will lose my angle attack protections. I will now have VLS and V-stall warning. I will lose my high-speed protections. The only protection remaining in alternate law is load factor protection. What I would notice on the primary flight display that I am not in normal law is that I would have amber X's on the bank indexes. I would have amber X's on my pitch indexes at 30 and 15 down, and VLS and V-stall warning, it would be a red and black barber pole. When I go gear down, if the autopilot is on, I would still maintain alternate law. If I turn the autopilot off, I would now revert to direct law. In direct law, all protections are lost. Bank, pitch, angle attack, load factor protection, and the high-speed protection. The side stick now becomes a directly proportional side stick in pitch and bank. I would notice this by all amber X's and an FMA across columns 2 and 3 that in amber would say use manual pitch trim. With the loss of all of the flight control computers, I would not be in any kind of flight control law. I would be in a mechanical backup. The way that I can control the aircraft is through pitch with the trimmable horizontal stabilizer, and with yaw with the rudder pedals, and also using the thrust levers. In order for this to be valid, I must have hydraulic. The indication of a mechanical backup, the FMA going across column 2 and 3 would be in red, man pitch trim only. Symbology on the speed tape. F represents minimum flap retraction speed to go to flaps 1. It is displayed when I am in configurations 2 and 3. S is minimum slap retraction speed. It is displayed in flaps 1. Green dot is displayed when I am in a clean wing. This represents the best lift to drag ratio in the clean wing. An amber equal sign on the speed tape represents VFE next. The red and black barber pole represents V max. Max speed 350, 2.82 for VMO, MMO. Landing gear extended, 280 knots. Flaps 1, 230 knots. Flaps 1 plus F, 215 knots. Flaps 2, 200 knots. Flaps 3, 185 knots. And flaps full, 177 knots. Frontier's policy: before extending flaps, we must be a minimum of 10 knots below each of the extension speeds. Except for going to flaps full, we must be 15 knots below the maximum extension speed. Landing gear panel. The computer that sends the information to the landing gear sensors is LG CIU number 1, and to the ECAM page it's LG CIU number 1 and 2. Auto brakes. In order to have auto brakes, you must have the normal brake system, the green hydraulic, and you must have a good brake steering control unit. If I fail either of those, I will not have normal brakes. With auto brakes, it takes a deployment of full ground spoiler deployment in order to get the auto brakes to start their process in motion. If I touch down one wheel, I will get a partial ground spoiler deployment. I need to compress the second strut in order for the ground spoilers to come fully deployed. I have to go to at least idle if the ground spoilers are armed, and I have to come to reverse on at least one engine if I do not arm the ground spoilers. Upon full ground spoiler deployment, auto brakes max would apply immediately upon ground spoiler deployment. Auto brakes medium, 2 seconds after ground spoiler deployment, and auto brakes low, 4 seconds after ground spoiler deployment. On the gear handle, a red down arrow represents that the landing gear is not down and locked in the landing configuration. The triple pressure indicator reads yellow hydraulic pressure only. If I apply the brakes and the aircraft is decelerating and the left and right brake gauges do not move, I am on normal brakes. If the left and right brake gauges do indicate pressure, I am on alternate braking system. If I have white diagonals across the captain's primary flight display, nav display, and the engine warning display, I have failed the number 1 DMC. In order to get the captain's instruments back, I need to go on the switching panel and select EIS DMC Captain on 3. Priority between the screens. If I have a failure of the primary flight display, it would automatically shift over and replace the navigation display. In order to look at a navigation display, I have to push PFD ND transfer. I do not have to push and hold it. Priority between the engine warning display and the systems display is the engine warning display. If it were to blank out, it would automatically shift down to the bottom and it would replace the systems display. In order to view the systems display, I can either transfer it using the ECAM ND transfer to either the captain or the first officer's nav display. Or I could leave the center screens as they are, and I can push and hold the particular systems page. Or I can push and hold the Alt key and look at each page individually. The auto thrust. The red buttons represent the instinctive disconnects. If I push them for more than 15 seconds, I would deactivate the auto thrust system for the remainder of the flight. Takeoff configuration push button. If I push the takeoff configuration push button, I'm checking the aircraft's ability to fly. Things that would be checked would be flaps in a takeoff range, slats in a takeoff range, pitch trim and rudder trim within their normal green band. Side stick, verifying a side stick is not locked out, and speed brakes being retracted. Upon applying takeoff power, it goes through this configuration check again, and now it adds checking for parking brake being set with power being applied, or a flex temperature not being set in the event that you're doing a toga takeoff. Emergency cancel is used to silence nuisance messages. On the engine panel, when I select the engine mode selector to ignition start, I will power the FADEC. I will bring up the engine page on the systems page. I will arm the master switches and the manual start switches, and I will close the air conditioning pack valves. If during the engine start I notice a fault light, the fault light on the engine master switch panel represents an automatic aborted start or a disagreement between the FADEC channels and the position of the HP fuel valve. Fire on that same panel represents that there is a fire on that particular engine. I think that's it. Any other questions?
And then...
How long did it take?
We got 42 minutes.
42 minutes. That was fantastic.
That was fantastic.
So how long do you think you're